Assalamualaikum students, today we will solve the MCQs of chapter 18 alcohols, phenols and ethers. First MCQ is, which of the following molecular formula represent the first three members of alcohol family? Now look at here, the first three member is, the one is methanol, second is ethanol and the third one is propanol. Okay, so option C is correct here. These three. Which bond will break when electrophile attack an alcohol? Now an electrophile when attacked, so it means that electrophile will be in search of an electron. Okay, now look at here, in an alcohol, if the C and O bond broken down, what will happen? This carbon will get the positive charge. Okay, so it means that the electrophile will not attack on CO. Look at the OH, when this bond is broken down, what happened? This O will get the negative sign. Okay, so this one will be suitable for the attack of an electrophile. So here option A is correct. The method for the conversion of alcohol into an alkyl chloride is treated the alcohol with. So when we treat the alcohol with SOCl2 in the presence of pyridine, dry HCl in the presence of anhydrous ZnCl2 and PCl3, so they will give the alkyl chloride, alkyl halide. Okay, so here option D is correct. All of the above, when we react them with the alcohol, so they will give the alkyl halide. Fourth one, which one is the best reagent to convert isopropyl alcohol to isopropyl bromide? These two are the given. Okay, when isopropyl alcohol is treated with one of them, it will give isopropyl bromide. Okay, when we react this one HBr with isopropyl alcohol, so it will give isopropyl bromide. Like this one will be H positive and Br negative. Okay, and this one will be OH negative and carbon positive. This negative Br will be combined to this carbon and it will give isopropyl bromide, and this hydroxyl group will combine to hydrogen and it will give the water. Okay, so A option is the correct one. The compound on dehydrogenation gives a ketone. The original compound is secondary alcohol. Okay, look at this one. Lucas test is associated with alcohol. Okay, option B is correct. In Lucas test, what happened? We find whether the alcohol is primary, tertiary or secondary. Okay, so option B is correct here. The compound which gives turbidity immediately with Lucas reagent at room temperature. So the turbidity means the cloudiness when the transparency is lost. Okay, so we know that at room temperature the order is that tertiary alcohol react first and then secondary alcohol react and then primary alcohol takes time. Okay, so in these options, option A is butane 2-ol, which is 2-ol is the secondary alcohol. Okay, its structure is like this. Okay, which is secondary alcohol. Look at the option B and C. These two are the primary alcohol. Okay, while option D is the tertiary alcohol. So immediately the turbidity will give, Lucas reagent will give turbidity immediately when it reacts with tertiary alcohol. Okay, so option D is correct. Look at here, this one is the structure for 2-methyl propane 2-ol. Okay, so it means that this one is the tertiary alcohol and it will react immediately. Decreasing order of reactivity of hydrogen halide acid is in the conversion of alcohol to the alkyl halide. So here option B is the correct one. Okay, HI will react easily and then HBr, HCl and HF. Okay, so this is the decreasing order of the reactivity of hydrogen halide. Okay, this one is the less reactive and HI is the most reactive. Glycols and glycerol can be differentiated on the basis of number of hydroxyl group. Okay, glycols have 2 hydroxyl group. Okay, and glycerol has 3 hydroxyl group. Okay, so option B is correct. Position of hydroxyl group classify alcohol into primary, secondary and tertiary alcohol. Okay, the position of hydroxyl group classify primary, secondary and tertiary alcohol. Now look at here, this one is the primary alcohol. Okay, when we bring this hydroxyl group here to the second carbon, it will give this one is now secondary alcohol. Now if the structure is like this, okay, if it is butane, isobutyl, alcohol. So here it is primary alcohol, okay, and if I bring this OH group here, okay, on this carbon, so it will become the tertiary alcohol. So it means that the position of hydroxyl group classified alcohol into primary, secondary and tertiary alcohol. Lower boiling point will be observed in 2-methyl and 2-propanol, okay, because look, boiling point is inversely proportional to branching, okay. Greater the branching, lower will be the boiling point, okay. Like, and look, this one is the tertiary alcohol, okay, propanol. 1 2 3, on 2 there is alkyl CH3 group, and here is the OH group, okay. So this one is the tertiary, so it will have lower boiling point. Dash makes alcohol less acidic than water. Alkyl group makes alcohol less acidic than water, okay. Now if you want to find the acidity of both, look at here, this one will take its electron and hydrogen will be released from water, okay. Now look at here, an alkyl group is attached to the alcohol. What will happen? This alkyl group is the donating group, okay, electron donating group. So due to this, the electron density around the oxygen increases, okay. So when the electron density around the oxygen increases, this density makes the oxygen more electronegative, okay. The negative sign is more powerful than in that case. So due to which this oxygen is not letting the hydrogen to release, okay, because we know that hydrogen is positively charged, okay, and this oxygen is very much negatively charged, okay, and this is because of the alkyl group. So due to which its bonding becomes stronger as compared to water, okay. When the bonding becomes stronger, what happens? This hydrogen will not release easily, and thus it is less acidic than water. The acid ionization constant Ka is highest for tertiary alcohol, okay. Option C is correct. Now look at here, this one is the primary alcohol, this one is secondary, and this one is tertiary. Now look at here, we know that greater the alkyl group, weaker will be the acid, okay. Now look at here, this R group is the electron donating group, okay. So in this case, the electron density around the oxygen increases, okay. So this oxygen make a stronger bond with hydrogen, so that's why this is less acidic, okay. But as compared to these two, this one is more acidic, okay. As compared to these two, this one is more acidic. So we can say that tertiary is less acidic than secondary, and it is less acidic than primary. Look at the secondary structure. There are 2 electron donating group, which means that the electron density around the oxygen will be much greater, okay. The negatively charged effect will be greater around the oxygen, so this oxygen will attract to the hydrogen toward itself more strongly. And look at the tertiary alcohol. There are 3 electron donating group, which means that the negative charge will be much stronger of this oxygen, so this will strongly attract the hydrogen, and in turn this tertiary alcohol will be weaker acid, okay. So we can say that Ka value is directly proportional to acidity, okay, is directly proportional to acidity. Now the lower the acidity, weaker the acids, smaller will be the Ka value, okay. Weaker the acid, smaller will be the Ka value. So here option A is correct, okay. Sorry, option C is incorrect, okay. Option A is correct. Primary alcohols are stronger as compared to these 3, so that's why the Ka value will be higher for the primary alcohol, okay. So here option A is the correct one, okay. HCl react faster with, look, this one is the HCl, okay. Now look at here, these are the alcohols, okay, tertiary, secondary and primary alcohol. We know that for acidity we have to break the bond between oxygen and the hydrogen, okay. We have to break the bond between oxygen and hydrogen, and here also for acidity we have to break the bond between hydrogen and oxygen. Now for reactivity we have to break the bond between carbon and the oxygen, okay. For reactivity, just break these 2 bonds, okay. For reactivity we have to break the bond between the carbon and the oxygen, okay. Now look at here, We know that the most stable carbocation is the tertiary one, okay? Like look at here, this one is the electron donating, this one is also electron donating, and this one is also electron donating group. Now when this bond is broken down, what will happen? This one will become tertiary carbocation, okay? Now look at here, this carbon has positive charge. It means that this carbon is in search of some negative electron, okay? Now this negativity is balanced, this positive charge is balanced by this electron donating group, okay? So it means that this one carbocation is the most stable one as compared to secondary carbocation and as compared to the primary carbocation, okay? So it means that this bond will be easily broken down, because after breaking this bond, what will happen? This carbocation is stable one, okay? So it will not affect its stability if this one bond is broken down. Now in these three alcohols, the most reactive one is the tertiary alcohol, okay? And the HCl will react faster with this tertiary alcohol. So look at the MCQ. Look at here, 1 pentanol, 1 butanol, 2 butanol, and look at this one, 2 methyl, 2 propanol. Option D is the tertiary alcohol. This one is the secondary and these two are the primary alcohol. So the first reaction will occur in the tertiary alcohol. Which one is our alcohol? Now look at here, alcohol is the one which is not directly attached to the aromatic ring, okay? Look at this one, these two are directly attached to aromatic ring, which means that they are not alcohol, okay? This one is also directly attached to the ring, so this one is not alcohol. Look at this one, it is not directly attached to this ring. Here carbon is present, so it means that this one is alcohol. And look at this one, it is attached to the R group, so this one is also alcohol. So the 3 and the 4 are alcohol. Look at here, option C is correct here, okay? Which alcohol will be easily dehydrated by using a dehydrating agent? So we know that tertiary alcohol is the most reactive one, so it will be easily dehydrated. Option A is the correct one, okay? 17. Esters are produced when ethyl alcohol is reacted with. So option D is here correct, okay? When acid and alcohol is treated, so it gives ester, okay? So acetic acid when react with ethyl alcohol, it will give ester, okay? And the reaction is called esterification, which is present in your book, okay? Tertiary alcohol shows no oxidation reaction. This is because they have no alpha carbon, okay? Sorry, they have no alpha hydrogen, sorry. Here option B is the correct. Look at here, this one is the tertiary alcohol. There is no hydrogen on this one carbon, okay? That's why oxidation will not occur. For oxidation, this is the condition that alpha hydrogen must be present, okay? So option B is correct. Look at here, the next structure is of primary alcohol, okay? Look here, alpha hydrogens are present, that's why oxidation will occur in these hydrogen, in this one alcohol, okay? So for oxidation, what happened? One hydrogen is removed, okay, and the hydroxyl group is removed from the carbon, and in that case the oxygen is attached to this one carbon, okay? Another oxygen is attached to this one carbon, and it gives the formaldehyde, acetaldehyde, formaldehyde, okay? When this one hydrogen is removed during oxidation, this one hydrogen is removed, this hydroxyl group is removed, water is formed, okay? So in that case oxygen is combined to this carbon, okay? So it will make the formaldehyde. And look at here, no alpha hydrogen is present here, so that's why oxidation will not occur in tertiary alcohol. Propanol is obtained when dash is oxidized. So when we oxidize the isopropyl alcohol, so in that case the propanol is obtained. Isopropyl alcohol is the secondary alcohol, okay? Look, this one is the isopropyl alcohol, okay? So when during oxidation, this hydrogen and hydroxyl will be removed, double bond will be oxygen will be bonded through double bond, okay, to this carbon, and it will give the acetone, or we can say propanol. Glycol oxidizes to different product. Ethylene glycol produce formic acid when treated with acidified KMnO4. okay, this one reaction is present in the cleavage of 1,2-diol or glycol. okay, so when we react with acidified KMnO4, it will give formic acid. When we react it with this one, okay, so this is called the periodic acid. okay, so it will give the formaldehyde. And now for formic acid we need acidified KMnO4. Thiols are the analogues of alcohol. okay, in alcohol we use ROH, while in thiol we use RSH. okay, so that's why this one is called thiol. Thiol or thioether contain dash element instead of oxygen, sulfur. okay, we know that sulfur and oxygen are in the same group. That's why in alcohol when we replace the oxygen it will give thiol when we replace the oxygen with sulfur. okay, mercaptans are represented by, look at the B option, RSH. okay, this one is also called thiol. RSH is also called thiol, or it can also called mercaptans. Thiols like methane thiol is added to the natural gas to detect its leakage. okay, option C is correct here. Phenol is also known as carbolic acid. okay, when we add 5% of water in phenol, so it become carbolic acid. okay, or we can say 5% solution of phenol is called carbolic acid. Or we can say 5% solution of phenol is called carbolic acid. Although carbolic acid contains 5% water, but still its formula is the same. okay, like OH. This one is the formula for carbolic acid, which is same like a phenol. 1,2-dihydroxybenzene is commonly known as catechol. Option C is correct here. okay, look, this one is the structure for catechol, 1,2-dihydroxybenzene. Carbolic acid is -% solution of phenol and water, 5%. The correct acidity order of carbolic acid, phenol, carboxylic acid, phenol, water and alcohol is, so the correct order is D. okay, carboxylic acid, phenol, water and alcohol. Look at here, in your textbook the Ka value of water is given as 10⁻⁻⁷. okay, here there is a table in your book, okay, for the acidity order, in which the value is 10⁻⁷ given, which is the wrong one. okay, the Ka value is 10⁻⁻14 for water. okay, please do correction there. okay, so it means that phenol is more acidic than water. okay, in Dove process phenol is obtained from chlorobenzene. Option B is correct here. Cumene or isopropyl benzene produces phenol on, option A, oxidation. okay, a reaction which can be used for the detection of phenol is the reaction of phenol with Br2. okay, we know that when a benzene ring is combined with hydroxyl group, what happen? This ring become activate, because hydroxyl group is the ortho para directing group. okay, that's why it make the benzene ring active. okay, so when hydroxyl group is added to a benzene, it become phenol. okay, and phenol is the most reactive one. That's why it react with bromine water, and due to this reaction we can detect the phenol in reaction. okay, and also due to this reaction the bromine water decolorizes. okay, when we react phenol with bromine, so it decolorizes. With concentrated nitric acid, phenol produces 2,4,6-trinitrophenol. okay, when the nitric acid is in concentrated, so it produces 2,4,6-trinitrophenol. Phenol, when reacted with X, it produces a tribromo derivative. okay, X is, so the X is bromine in water. okay, option A is correct. This is the reaction of halogenation of phenol, or addition of bromine with phenol. okay, so we use the bromine in water, or which is also called bromine water. Which one of the following is not a phenol? Benzyl alcohol is not a phenol. okay, we know that when hydroxyl group is directly attached to the ring, so it will be a phenol, but in this case the hydroxyl group is attached to the carbon atom. Okay, so it means that this one is not a phenol. Which one of the following is more acidic? So here we know that water is more acidic as compared to phenol. Okay, water is more acidic as compared to alcohol, so option A is correct here. Look, the order is like CPAW. Okay, carboxylic acid, phenol, water and alcohol. Okay, this one is the pattern. First acidity is of carboxylic acid, then phenol, then water, and the next one is alcohol. Okay, so these three are alcohols, that's why option A is the correct one. And I told you in the previous MCQ that the reason of the low acidity of alcohol is because of the alkyl group. Okay, which one of the following is not soluble in acid H2SO4? Okay, so here option D is alkane. So this one is not soluble in H2SO4. Okay, because we know that they are the paraffins and saturated, that's why they are not soluble in H2SO4. Ether have boiling point higher than alkane but lower than alcohol, because now we know that ether is a polar molecule. Okay, because oxygen and carbon is present there, so it means that because of oxygen they are polar, and alkane is non-polar. Okay, so it means that ether has higher boiling point because of the polar nature. Okay, but lower than alcohol. So we know that alcohol has oxygen and hydrogen. Okay, so it means that this alcohol is able to make the hydrogen bonding, while ether has only oxygen, and the oxygen do not have any hydrogen atom, so that's why ether is unable to make the hydrogen bonding, so its boiling point is lower than alcohol. So look at here, option C is correct. Okay, ether are polar but do not have hydrogen bonding, that's why it has higher boiling point than alcohol and higher boiling point than alkane and lower than alcohol. Okay, 38. Rectified alcohol is 95%. Okay, 95% alcohol in water. Which one of the following undergoes dehydration with ease? So we know that tertiary alcohol is the more reactive one. Okay, so it means that it will react easily, okay, with another substances. So dehydration with ease will tertiary butyl alcohol. Okay, which one of the following is more soluble in water? Now this one means that which one of them will be easily surrounded by water. Okay, we know that in solubility the water molecules surrounded the substances, okay, like methanol or anything else. So we know that methanol has smaller size, that's why this methanol can easily be surrounded by water. Okay, so it means that methanol is more soluble in water. Option A is the correct one. Okay, which one of the following compound does not liberate carbon dioxide reaction in reaction with Na2CO3? Sodium carbonate. So here sodium carbonate is a weak base, okay, and HCl is a stronger acid. Now when we react these two, what will happen? NaCl, water plus carbon dioxide will produce. Okay. Look at this one. When we react H2SO4 with Na2CO3, sodium carbonate, so we will get sodium sulfate, carbon dioxide plus water. Okay, and when we react the HNO3, nitric acid, so we will get sodium nitrate, carbon dioxide and water. Now when we react phenol with sodium carbonate, what will happen? Carbon dioxide will not produce. Okay, and phenol do not react with sodium carbonate, that's why option D is the correct one. The alcohol which resists oxidation is tertiary butyl alcohol, because this alcohol do not have hydrogen. Okay, look, this one is the tertiary alcohol. So this one carbon do not have hydrogen which is directly attached to it, okay? So that's why this one will not undergo the oxidation, okay? So option D is the correct. For oxidation, this carbon must have hydrogen. In esterification reaction, which one of the following bond of alcohol undergoes the cleavage? So here option B is the correct one, okay? The OH bond undergoes the cleavage. Which one of the following alcohol does not undergo the dehydration reaction? Here we know that dehydration reaction is the elimination reaction, okay? And elimination reaction, what happens? The sigma bonds are broken down and the pi bond is formed. Now look at here, methanol. Methanol is the CH3OH, okay? Now for methanol, there is no another carbon due to which we can make the pi bond, okay? Look at here, for dehydration there must be two carbon, okay? Two adjacent carbon, from one carbon hydroxyl group is removed and from another carbon the hydrogen group is removed, and due to that the pi bond is formed between the two carbon atoms, okay? But here look at the methanol, there is no another carbon atom. That's why we can say that the methanol do not undergoes the dehydration reaction. Look at this one example. This one is the ethanol, okay? So this one undergo the dehydration reaction. When we remove the hydroxyl group from this carbon and hydrogen group from this carbon, then what will happen? This one carbon will get positive charge, okay, and this one will get the negative charge. So this positive and negative, so they will make a pi bond, okay? So we can say that this one ethanol can undergoes the dehydration reaction, okay? This one can undergo the dehydration reaction, while methanol does not undergoes the dehydration reaction. When treated with acid, dash produce the ozonium salt. So ether produce the ozonium salt.